Okay, this is design assignment 2C, part 1A, in which we will be creating a waveform with a 60% duty cycle and a period of 725 milliseconds. In this example, we're going to have the time on should be 435 milliseconds, which is 60% of the period, and the time off is supposed to be 290 milliseconds. Since it's reverse logic on the microcontroller, we'll see that the waveform on the oscilloscope will actually show the time low being 435 milliseconds, but that's okay. Here's our C code running. Output on the actual microcontroller. You can see that it's on a little bit longer than it's off. And if we come over here to the oscilloscope, we can see that waveform there. As I said, it's reverse logic. We can stop it and measure one period. With our cursors. So, see that one period measures to be right around 720 milliseconds, so it's not exact. It's off by 5 milliseconds. That's because in the code we can only use integer values for the overflow counter. For the time off, I calculated about 17.7, and I have to use the integer value 18, and for the time on I calculated 26.5, so going up or down wouldn't really matter. It's either going to overshoot or undershoot. But as you can see, 720 milliseconds there. Actually, if we make the seconds per division a little bit longer, it'll probably get more accurate. Let's see what we get here. It's still 720, that's fine. So 720 millisecond period, the time off, which is reverse logic, so it would actually be the calculated time on is 428 milliseconds. Calculated time was 435 milliseconds, so that's off by 7 milliseconds. And the time off, which is going to show up here as the time on due to reverse logic, is 292 milliseconds, which was calculated to be 290 milliseconds. So yes, that is design assignment 2C part 1A.